Hello everyone. Today we will start a new topic, surface area and volume. But before we go to surface area and volume, let us look at a few things that we have learned in our earlier classes. Let's take this particular shape. This is a two-dimensional shape. This is called a square. A square is something in which all the sides are equal in length. So this is a square, and in a square, suppose this is of side A, there are two things that we need to know in this. One is perimeter. What is the perimeter? Perimeter is the length of the outer boundary. So what is the length of the outer boundary? If I start from here, this is A plus A plus A plus A. So it is 4A. The perimeter is 4A. And what do you mean by the area? The area is the space inside the square. So the area of the square, how do you measure it? What is the formula? It is nothing but area is A into A, which is A square. Now, let's look at the other one that we know. This is it's a rectangle. So rectangle, so it has a length and it has a breadth. So here it's same, it is also the same. The opposite sides are equal. Now, and it's 90 degrees over here. Now, the perimeter of this would be L plus B plus L plus B. It's nothing but 2 into L plus B, and the area of this would be L into B. So the area is L into B. Now, what are the other ones that we know? Suppose we have a triangle and you have A, B, C. The perimeter would be A plus B plus C. Another way to find the area if given three sides is using the Heron's formula, square root of S into S minus A into S minus B into S minus C, where S is a semi-perimeter, is equal to A plus B plus C by 2. The other formula that we know how to find the area of a triangle, if we are given the height, so from this vertex, let's say this is ABC, this is small c. So from here, this is D, this length is C. So this D, the AD is the height of this triangle and the BC is the base. So the area would be half into base into height, which is nothing but half into BC into AD. Okay, so we saw the square, the rectangle and the triangle. Now, another shape that we know is the circle. And every circle has a particular radius. So in this, the perimeter is also known as circumference. So the circumference is equal to 2 pi r, and the area of the circle is equal to pi r square. These are all things that we have learned in earlier classes. We are just revising it before we go on to volume and surface area. Now, let us look at the first shape in first three-dimensional shape of the day. That would be, let me draw it, you can find out what it is. This is a cuboid. So what is a cuboid? You've seen cuboids all over the place. So cuboid looks something like this. See this box? If I look at it on one side, it's a rectangle. See, length and breadth. If I take that as the length and the breadth, and there is a height over here. It is as if this rectangle has been raised out to a certain height. So it becomes what is called a cuboid. So there are three things over here. So this is length. Okay, so let's take this length, this is breadth, and this would be the height. Okay, so there are certain terminologies which we need to be very clear with. So how many faces does this cuboid have? 1, 2, 3, 4, 5 and 6. There are 6 sides or faces that it has. And wherever any two faces meet, it's called an edge. So how many edges does it have? 1, 2, 3, 4, 5, 6, 7, 8, and we have 9, 10, 11 and 12. So we have faces 6, we have edges 12, and wherever these edges meet, it's called a vertex. See this, one edge, two edge, three edge, all these three edges meet at this place. It's called, this pointed place is called a vertex. So how many vertices does it have? 1, 2, 3, 4, 5, 6, 7 and 8. So vertices 8. Okay, so now suppose we have this cuboid, and if somebody asks what is the surface area, so it's basically the area of each of the faces added together. So you have this face, you have suppose the down area would be, it's a rectangle which is L and B, so it is length into breadth. So this bottom would be length into breadth. So length into breadth. So there are two such faces. So it is 2LB. Similarly, I can have this length into height, this side, and that is equal to this side. So I have 2 length into height, and another one, breadth into height on this side, and you have a similar one on the other side, breadth into height. So that is 2 into breadth into height. So the total surface area would be 2 into LB plus 2 into LH plus 2 into BH, or I could write it as 2 into LB plus BH plus HL. So this is the surface area of the cuboid. Now we come to the volume of the cuboid. Volume is nothing but length into breadth into height. Length into breadth into height. That is the total volume, or how much space does this occupy. That is what volume gives you. So it is length into breadth into height. And another interesting one. So suppose I were to draw a diagonal from this point here, you see this point, to that corner there. So that would be the biggest diagonal that you could draw inside this. So this diagonal, what would be the length of that diagonal? Length of diagonal. That would be square root of L squared, length squared, plus breadth squared, plus h squared. You might be wondering how is that done. So suppose I take length and breadth. What would be the diagonal here, the base if I have to draw a diagonal? That would be, again, all of these are 90 degrees. So this would be, I can say this diagonal square would be equal to L squared plus B squared. L squared plus B squared. And what is this? This is the height. So if I have to draw another diagonal which is if I draw a line connecting this point and to this point, and so now I know that one side is this and the other side is the first diagonal that we drew. So this in turn is another right angle triangle. So h squared plus b square will give you this diagonal. So the final diagonal by df square would be d square plus h square. So d square is l square plus b square plus h square. So this would be d square. So d would be square root of l square plus b square plus h square. So these are the main concepts that you need to keep in mind for the cuboid. Now let us look at the cube. So what is a cube? A cube is nothing but a cuboid in which the length and breadth and the height all are equal. So you must have seen these Rubik cubes. These are an example of cubes. This, let's say, length, breadth, height, they are all equal. So if I take a cube, in this all sides are equal. So let's take that as side length is A, or the edge length basically you will say is A. So the area is 2 into A square plus, we saw that 2 into LB plus BH plus HL was a cuboid. So LB is nothing but A into A plus again A into A plus again A into A, which is A squared plus A squared plus A squared. So we totally have 6A squared. That is the surface area of a cube. And the volume would be A into A into A, because L into B into H, here everything is equal. So A into A, which is a cube. So this is the volume of a cube. And the diagonal of the cube, that would be square root of A squared plus A square plus A square. So it is root 3A square. The square root of A square is A. So root 3A is the length of the diagonal in a cube. So I want to draw this cube. It's like this. A and A. So here we have seen area, the volume and the length of the diagonal of the cube and the cuboid. Now let us look at solving some problems in our next session.